Welcome to another tutorial. In this question, we are to find the value of x and y in this equation. Now, to solve this, we first of all let y equals to kx, where k is a constant. Now, we have to introduce that constant to this question in order for us to be able to find the values. So the next thing we are going to do after introducing the constants, we substitute y into this equation. So y here is kx. So wherever we see y, we are going to put kx. So x equals to kx, and y is kx here. So we put kx raised to the power of x. After that, we will take the square root of both sides. So we say the square root of x raised to power kx equals to the square root of kx raised to power of x. Now, let us write the square root in fraction form. That's 1 over 2. This is the square root. This can also be written as x raised to power kx bracket 1 over 2. We do that to both sides. Kx raised to power of x is power 1 over 2. Now, let us multiply. You simply say kx times the numerator, which is kx times 1. We are going to have x raised to power kx over 2 equals to, we have kx here raised to power x over 2. We now want to write this side to also have x over 2. So we have to bring out x over 2 using this law of indices. So we have to write this kx over 2 in this form. A raised to power mn is the same as a raised to power m bracket n. So we'll bring out x raised to power 2. So we have x raised to power k bracket x over 2 equals to kx bracket x over 2. Now, the next thing we are to do is to eliminate this x over 2. So, to eliminate x over 2, we multiply the powers by 2 over x. This power we multiply by 2 over x. Let's go ahead and solve that. X raised to power k, x over 2 times 2 over x. We do the same thing here, x over 2 times 2 over x. So this 2 cancels this 2. This one cancels this one. This 2 here cancels this 2. X here cancels this x. We now have x raised to the power of k equals to kx. Now, while we are doing all this, we are trying to make x the subject of the formula here. So don't get confused. You are trying to make x the subject of the formula. So the next thing we are to do now, we are still trying to make only x to be on one side of the equation. In this question, let's divide by x on both sides. We have x here, we have x here. So we divide by x. This x cancels x. We are left with x raised to power k over x equals to k. So k here equals to x raised to power k all over x. So we are going to write it in this form. if a equals to a raised to power m all over a raised to power n equals to a raised to power m minus n. So now we are going to write this k in this form. So this is 1. This x here have the power of 1. The exponent is 1. So we write it as k equals to x raised to the power of this k minus 1. We are trying to make x the subject of the formula here. So we are trying to eliminate everything to allow us to have x, make x the subject of the formula. So the next thing we are going to do, we multiply the exponents of both sides of this equation by 1 all over k minus 1. So raised to power 1 all over k minus 1 equals to x k minus 1 by 1 all over k minus 1. So now this k minus 1 will cancel this k minus 1. So we have k raised to power 1 all over k minus 1 equals to x. So x here equals to k raised to power 1 all over k minus 1. So we have found our x. So since we found x, let us substitute x into this formula, which is y equals to kx. So let's substitute x into this formula in order for us to find y. So here we have y here equals to k times the x is k raised to power 1 all over k minus 1. So we have substituted it. So here we rearrange, this is going to have the power of 1. So we arrange y to be y equals to k raised to power 1 plus 1 all over k minus 1. So this is the value of y. And this is the value of x. This is the value of x. Now, to solve further, to check if we are correct, let us say k here is a constant. Now, to solve further to prove if we are right, so let's say if k equals to 3, k is a constant in this question. So let's substitute k into x and see what it will give us. So x equals to k raised to power 1 over k minus 1. So x, let's substitute 3 wherever we see k. So this 3 raised to the power of 1 all over 3 minus 1. So that will give us 3 minus 1 is, that will give us 3 raised to power 1 all over 2. So 3 raised to power 1 over 2 is the same as the square root of 2. So of 3. 3 raised to the power of 1 over 2 is the same thing as square root of 3. So x equals to the square root of 3. So now let us substitute 3 into y. k equals to 3. Now let's substitute 3 into y. So we have y equals to 3 raised to the power of 1 plus 1 all over 3 minus 1. So we have y equals to 3. So we have 1 plus 1 all over 3 minus 1 there. So we'll have 1 plus 1 all over 2. Now, when you add that up, when you add 1 over 2 plus 1, you have 2 here. 1 plus 2, we have 3 over 2. So we have y will be equals to 3 raised to the power of 3 over 2. To rearrange this one will be the root and this will be the power. The denominator is the root and the numerator is the power. So y will be equals to the square root of 3 to the power of 3. So this is the value of y, and the value of x is the square root of 3. Now, after finding the constants, let's check if the right hand side and the left hand side are going to be equal. So y equals to the square root of 3 raised to the power of 3. Now let's substitute x and y into this question. So x is root 3 raised to power y, which is root 3 raised to power 3. And y is root 3 raised to the power of 3 raised to the power of root 3. So let's write the root sign in fraction form. We have root 3, then 3 raised to power 1 over 2 power 3 equals to root 3 and 3 here raised to the power of 3 1 over 2. Now here we multiply root 3. We multiply 3 by this one. We have 3 here. 1 times 3, we have 3 over 2. And when we come over to this side, we have 3 here. And we add there's exponent of 1 here, power of 1 here. We add the power. We add the power. And we have 3 whole number. 3 over 2. So now, the right hand side equals to the left hand side. So we have proved it. Proved. Kindly subscribe to my YouTube channel. Thank you for watching. Bye.